Sometimes you will be asked to write the equation of a line that is perpendicular to a given line and goes through a particular point. So this is very similar to what we do when we have parallel lines. The only thing that changes is the slope of a perpendicular line is different. However, the rest of the process is the same. So the first thing we want to do is look at our equation and identify the slope of the line perpendicular to this one. So as you recall, last class, we said that perpendicular lines have slopes with opposite signs and they're reciprocal of one another. If we look at the line that we're given, we can hopefully identify that its slope is 3 because it's in slope-intercept form and x is being multiplied by 3. So if we're given a line with a slope of 3, remember that the number 3 is the same as 3 over 1. Sometimes when we have a whole number, it's easier to find the reciprocal if we put it over 1, because then we can flip it to get the reciprocal of 1/3. All right, so 3 and 1/3 are reciprocals. And remember, the definition of reciprocal is that their product is positive 1. So when I multiply 3 times 1/3, I get 3/3, which is the same as 1. Okay, so we successfully found the reciprocal of 3. However, that's not our slope for our perpendicular line because they must also have opposite signs. So the slope we want is going to be negative 1/3. All right, so if we think about what we know about our new equation, we already know that the slope is negative 1/3. Oops, don't forget your negative. I almost did. Okay, the rest of the procedure is exactly like if the lines were parallel. So we just need b so that we could write this in the form of y equals mx plus b, where x is our independent variable, y is our dependent, m is our slope that we already know, and b is our y-intercept. So just like we did before, we're going to come to the points that we were given, and we're going to take the x and the y values, and we're going to substitute them into our equation. So instead of y equals, we could start with putting our slope in negative 1/3 x plus b. I'm now going to take the 2, which is my y value from that point, and then I still have my negative 1/3, and now my x value, which is negative 6, plus b. Now you're welcome to use a calculator, but it's not too difficult to multiply negative 1/3 and negative 6. So you might want to do that multiplication out here to the side. Negative 1/3, remember when we multiply fractions, if we have a whole number and a fraction, we want to put the whole number over 1. And now we just multiply the numerators and the denominators. So negative 6 times negative 1 is positive 6. 3 times 1 is 3. And that simplifies to the whole number 2. All right, so going back to the work we're doing, 2 is equal, we said negative 1/3 times negative 6 is 2, plus b. So now we are still solving for b. We could subtract 2 from both sides, and we get that b is equal to 0. So the equation of our line, we could really write it two ways. We could write y equals negative 1/3 x plus 0, or that 0 is really unnecessary. We could just say y equals negative 1/3 x, because anything plus 0 is just itself. Let's just summarize this process one more time. So when we are asked to write an equation of a line that is perpendicular to a given line and goes through a particular point, we're going to first identify the slope of our new line. Unlike parallel lines, it's not the same slope. The slopes have to have opposite signs In other words, one is positive and one is negative, and they must also be reciprocals of one another. Then you're going to substitute the x and y values into the equation. So the x for x, the y for y. We know our slope from step 1. The only variable in our equation is b. We're going to then use algebra. We'll solve algebraically for b. Once you get b, you can go back and rewrite your equation. Y equals your slope from step 1 times x plus b, your y-intercept from step 3.